guys, so last time we were calculating areas and we approximated the area under a curve by doing the approximation using rectangles, and then in the book you read that these were called Riemann sums, and you then took a limit and you defined that as the definite integral of the function between the endpoints a and b. And so, for example, before we state the first fundamental theorem of calculus, if you have your endpoints 0 and 3 that we did in that example, this area that we were approximating would just be the definite integral between 0 and 3 of the function. The function is 9 minus x squared. And so the question is, how do we calculate it? Well, we were approximating this quantity by basically doing rectangles, and the more rectangles we took, the closer and closer we were getting to that value, which, remember, I told you it was 18. We're going to calculate it, or I want to show you how I calculated it in this video. And we're using the first fundamental theorem of calculus that basically will state that if you have the function, this little f here would be this 9 minus x squared, and a and b would be 0 to 3, the way to calculate it is, if you can find an antiderivative for that function, then you just have to evaluate that antiderivative at the right endpoint, so b, and then subtract that antiderivative evaluated at the left endpoint, or a. So here, what I would have to do is find an antiderivative for this function. Namely, I could write 9x minus x cubed over 3. That's an antiderivative. I don't have to write plus c, because I can choose just any. But then I evaluate between 0 and 3. So whenever you're doing these definite integrals, you don't have to necessarily write plus c. Essentially what you're doing is you're choosing c to be 0. And that is okay, because whenever you evaluate it and subtract it off, the constant vanishes nonetheless. So there's no loss there. So with all that said, once you calculated your antiderivative, and I explained the reason why I didn't put plus c, now you can evaluate it. And evaluate this function at 3, we get 9 times 3 minus 3 cubed over 3. Then minus, remember, if you look up here, this term that I wrote would be f of b, and then minus f of a. So I subtract, and I put my parentheses here, and I evaluate the other function at 0. The same function, sorry, at 0. I'm going to write it all even though it's 0, just so you see how it's done. This is f of 3, capital F of 3, and this is capital F of 0. And then you just evaluate everything. 9 times 3, 27, minus 3 cubed is 27, over 3 is 9, and then minus, all this ends up being 0, and I get 27 minus 9, which is 18, and I'm still going to write my units squared to indicate that we're considering an area. Alright, let's do one more so that it all becomes clear. So let's say you have the function y equals x squared, let me zoom in a little bit, x squared minus 4x between negative 4 and 2, and this would be the graph, and you would be looking for this area right here. This area is just going to be the definite integral between negative 4 and negative 2. I use my left and right endpoints of the function, so just x squared minus 4x dx. And the first fundamental theorem of calculus allows me to evaluate this by simply finding the antiderivative here. So it would be x cubed over 3, or an antiderivative, and then minus 4x squared over 2, which is going to be 2x squared. And I evaluate it between negative 4 and negative 2. I said it backwards, negative 2 and negative 4. Alright, so then you just evaluate and this is going to be negative 8. I should have written negative. Let me write it all. So negative 2 cubed over 3, I'm evaluating at negative 2, minus 2 times negative 2 squared, then minus, and I put parentheses, and then I write negative 4 cubed over 3, and then minus 2 times negative 4 squared, and then I close my parentheses. This right here, so this big first parenthesis would be f of b, and this would be minus f of a. B would be negative 2, and a would be negative 4. Alright, so now we evaluate it. We get negative 8 over 3. This one is going to be negative or minus 2 times the negative 2 squared becomes positive 4 times 2, so minus 8. And then minus, and I evaluate it here, I'm going to have put your parentheses firstly, and then you get negative 64 thirds, and then minus again, and then you get negative 4 squared 16 times 2, 32. And then you calculate everything, and you get here negative 8 plus 64 is going to be 56 thirds. Sorry, somebody came by the door. And then here I get negative 8 plus 32, so plus 24. And that will give you equal to, let's see, I need to multiply this times 3, so it's going to be 56 plus, then I'm going to have what, 72 over 3. And that's going to be 128 thirds. And that's that. I'll finish this video here, and I will continue with other examples in the next video. So if you have any questions, just let me know or put a comment in the video below. Thank you so much for watching, and I'll see you in the next time.